Hi Nico, Rodrigo, and Tristan. This is Miss Skokin, and as you know, I recorded a video for you so that you would be able to catch up on the notes on section 9.2 while you were away at the Washington trip. And this is the part of section 3 that our class went over on Thursday. What ended up happening is we went over 9.2 on Tuesday and Wednesday, the fusion period, and then on 9.3 we started section 9, on Thursday we started section 9.3, but we didn't quite finish it, so we will finish it on Monday when you're actually in class. On Friday, we worked on the Chapter 8 test corrections, and students did not get their tests back, but what we did is every student got 1 or 2 questions to work on in class, and then students were taking turns coming up to the front and writing down or explaining the corrections, the correct way to solve each one of those questions. So you'll be there for 10 through 18. I think that's where we left off, is number 10. So you'll be there, and then we'll finish that on Monday, and then we'll resume our section 9.3 notes. And of course you'll be there for that once again. So I just wanted to get you through the part of 9.3 that you missed. So the learning objectives are determine properties of reciprocal functions and graph transformations of reciprocal functions. Vocabulary, reciprocal function, hyperbola, and asymptote. And a reciprocal function is a function in the form f of x is equal to 1 over p of x. P of x is a polynomial, but it's a polynomial that is a linear function. So it's going to be in the form y equals mx plus b, because once again it is linear only. And of course we cannot have division by 0, so p of x does not equal to 0. So what I'd like you to do now is write down the points, write down the x's that we used in the xy table, and you can copy down the y's or you can calculate them yourself and then graph the points on the grid. You'll see that we have a new shape that we haven't seen before, and it is called a hyperbola. You'll notice that the red lines, as we come in from the left, from the negative x area, it gets closer and closer to the y-axis, but then it turns away from the y-axis and goes to the negative y direction. On the other side, it resumes again at 0 at the y-axis, and then it curves away from the origin. It gets closer and closer to the origin, and then curves away and goes into the positive infinity direction for x. This shape is called a hyperbola, and you'll notice in yellow that we have asymptotes, and those are the lines, the horizontal and vertical lines, that the reciprocal function gets closer and closer to, but never actually crosses. If you need to, pause the video now so that you can finish filling in the XY table and graphing the function. Once you're through with that, turn the video back on so you can fill out the information in the domain, range, x-intercept, y-intercept, asymptotes, and undefined values. So pause the video now. Okay, now that you have turned the video back on, you've got the graph and you've got the XY table finished, write in your own words, or of course you can use these words, what an asymptote is, and also fill out the little table. You may have done that already by yourself looking at the graph, and of course that's fine. Just check your work here. Once you're done, turn to the next page where we're going to be graphing, and what I'd like you to do is use the graphing calculator so that you can graph the 4 functions with their transformations that are shown on this page. You can use the graphing calculator if you need the graphing instructions. I've written it, for example, for the 1 over x graph. Go to y equals on the graphing calculator, and I'll show you right here. The graphing calculator, here's the y equals button, and I'll go ahead and clear out this function that we have. And what you would do is you would put in 1 over x, and of course this is the key right here, right under the mode key, where you would find the variable. So you put in 1 over x, and then what we would do is zoom standard. So the zoom key is right under the screen, and then standard in this case is choice 6. Depending on what version of calculator you have, you might be a little bit different. And you can see the hyperbola that we just graphed on the previous page. It does, some of the calculators will show the asymptotes and some of them won't. So it just depends on the operating system you have. Now what I'm going to do is I'm going to zoom in a little bit more. So I'm not going to use the zoom key. I'm actually going to change the window. And the window key again is right underneath the screen of the graphing calculator. I actually would like it to go from -5 to +5 in both the X and the Y direction, because it's going to help us to see just a little bit more. So if you want to change your window also on your graphing calculator so you can kind of be a little bit more zoomed in, you'll see on the graph it looks a little bit clearer. And then the other thing that I'd like you to do is when you're using the graphing calculator to graph these 4 functions, you might want to use the XY table to graph the points, the individual points, and then draw the curves after that. You can use second graph to get to the table, and as you can see here, it gives you the XY table for the function. Now here, you notice at 0, it shows error, and that's where we have our vertical asymptote. Now something that you may want to do is change how your table is defined. So you can do second window to go to table set, and you can tell it where you want your XY table to start. In this case it says -3. We could change it, for example, to -5 or 100. And we have it changing by ones. So it starts at -5, then -4, then -3. Those are the X values that are going to be shown in our XY table. So we'll go back to the XY table, and you can see it changed it to -5. So graph the functions, graph not only the points but the curves, practice using the graphing calculator, and then on the lines below the graphs I would like you to write down your observations about the domain and range of the functions A, B, C, and D, and anything you want to write down about the transformations, asymptotes, undefined values. Those are all related pieces of information. And when you're done, I would like you to turn the video back on to check your answers. Okay, so you've turned the video back on now, and you can check your answers. You saw the first 2 graphs to begin with, and I'll show you now the observations that I made about the first 2 graphs. So you can check your answers on those. The domains, we have multiple ways of being able to write the domains. For the red one, it's in words, and in the blue one, 2 over x being that function, we wrote it in set notation. It's also possible to write it in not inequality notation, set notation and interval notation. That's what I was thinking of. And interval notation we learned back at the beginning of the year. I'm not sure, somewhere in trimester 1 anyway. If you need some help with that, let me know. But it's something that's going to become more important in pre-calculus, less important in Algebra 2 honors. But still, if you want some information about that, let me know and we can work on that. I'll scroll down now to the last 2 functions, and you can check your work on those. Pause the video if you need to so that you can check your points and your graphs. And then pause the video if you need to write down the observations about domain, range, asymptotes, and the analysis of the transformations of the functions. Okay, on the next page of notes, we're now on page 11. And on this page of notes, you can see that we want to find the values for which this function is undefined. And undefined values are where the denominator would be equal to 0, or where we would have division by 0 in the rational function. So what we do is we set the denominator equal to 0 and then find the values that will make that equation true. So in this case, once we set it equal to 0, factor and solve, we have 2 values for which the function f of x is undefined. X is equal to 6 and x is equal to -4. Either one of those would cause division by 0 and the function would no longer be defined. We would have, in that case, an asymptote at both of those locations. If you try this on your graphing calculator, you would need to make sure to put a parentheses around the denominator, so it would be 4 over and then the polynomial x squared minus 2x minus 24, and you'll see that you have 2 asymptotes on that function. So I've brought the graphing calculator back and have put in the the function, and then we'll graph so we can see what it looks like. And you can see we have two asymptotes shown here. We can't actually see both of them because of our window, so we'll change our window. Actually, we'll just do zoom standard so we can see from -10 to +10 in both the x and the y directions. So you can see, I know it looks a little bit funny, but you can see where our asymptotes are located. If we change the window once again, we might be able to get a better picture. So you can see that I've changed my window here, and whoops, I need to clear that out. Sorry about that. Okay, so I've changed my window and I'm going to graph, and you can see what our function looks like, the asymptotes at -4 and +6, and that the function curves around those two asymptotes. So as we look at the notes for questions number 3 and 4, these are going to be where we take a look at the function, predict the transformations, look at the undefined values and asymptotes, and then, of course, domain and range, and then graph the function. So in this case, our function is f of x is equal to 1 over the quantity x plus 1, and that added that to that 3. So our parent function is f of x is equal to 1 over x. We use what we know about transformations from previous chapters, and we know that we have a vertical translation 3 units up, and we also have a horizontal translation 1 unit to the left. Although this function, because of the numerator in the fraction, we're going to have the same size and shape, meaning no dilation. Where do we have undefined values? When x is equal to -1, we would end up with division by 0, so that's an undefined value. Where do we have asymptotes? Where x is equal to -1, that's the same as our undefined value. We're going to have a vertical asymptote, and we will have a horizontal asymptote when y is equal to 3, because our entire function will be moved up 3 units. That's where we left off on Thursday, and where we will pick up again in class on Monday as soon as we finish our test corrections for Chapter 8. So again, welcome back to class. Glad you had a great time on the trip, and we'll see you on Monday. Have a good weekend.